In this video, I'm going to demonstrate some best practices in object-oriented development and show how they can be used to write a program without if test, a complicated program at that. But why? Well, we want to see how best practices can help us write better code. Things like the solid principles, which we'll cover in just a moment. Also, API, abstraction, polymorphism, inheritance, encapsulation. And we want to take a look at design patterns as well. This example is based off of something that happened early in my career when I worked for a bank in downtown Cincinnati. By the way, if this view looks familiar, don't be surprised. It is familiar. Nonetheless, I was working downtown Cincinnati, and I remember very well when it was. It was in 2001, and I was probably at the time about 4 years out of college. So I was really kind of maturing my own understanding of object-oriented programming. And I took training from Sun Microsystems, who at the time had created and basically had ownership of Java. And the trainer told me two things that absolutely changed my perspective on programming for the rest of my career. One is, you can judge the quality of an object-oriented program by counting the if tests. The fewer, the better. And at the time I thought, I write if tests all the time, I'm doing something wrong. Then the other thing he says is, if you're not using interfaces, you're only using half of Java's potential. And once again, I thought, I'm not using interfaces. And so I decided just to figure that out by myself. What did he mean? And I decided over the next year to try to avoid if tests at all costs. That was objective number one. Once I got the hang of that, I was going to start figuring out what interfaces really were. 9 months later, it all clicked. It took that long, but it all clicked when I was in charge of writing a program that handled files between the bank and the credit card company. So a bank can issue credit cards to customers, like the credit card in your wallet. That's called the issuing bank. Or a bank can process transactions for merchants, which is called the acquiring bank. And so the bank I worked for did both. And I was working on a program for disputes. So if you disputed a charge on your card, there was a 10-step process. I was originally told a 9-step process, but it was a 10-step process, and I decided, okay, I'm going to do this entire thing without an if test. I was rewriting a program that already existed, and I thought, okay, I want to see when my program's finished how it compares to the one that I started with. The one I started with went through steps 1 through 4. Mine had to go all the way through step 9. The program I started with had 5,000 lines of code. The one I finished with, which had more than double the functionality, had 1,000 lines of code. And when you think of lines of code, I seriously counted it because I was curious. Oh, one other difference is that the program I started with was 1 class and basically 3 methods. The program I ended with was 36 classes. So many more classes, but much, much less code. And when I think of lines of code, I think about my old house and my current apartment. My current apartment I can clean in about 55 minutes because I know how big it is. It's a typical apartment. My old house, I never figured out how long it took to clean because every time I finished I had to start again, and it was a never-ending process. Source code's the same way. The more code you have, the more it takes to maintain. The less code you have, the less it takes to maintain. So that's why we like finding ways to do more with our code, but with less lines of code. And I hope this video will give you some ideas on how to do that. So how are we going to program without if tests? Well, we need to take a look at the solid principles. Single responsibility. Each class should do one thing and have only one reason to change. We'll look at that. Open-closed principle. Put logic in the right places. And I'm paraphrasing these a little bit here. Liskov Substitution. Each class that implements an interface can be substituted for that interface when we have a variable declared of that interface type. Interface segregation. The interface contains only the methods required to do the work, no more, no less. Dependency inversion. When we have an interface and several classes that implement that interface and we need to interact with those classes, the variable type or the way that we interact with those classes should be the interface type, not the subclass type, not the implementing class type. API and one of my absolute favorites, and I'll tell you, if you don't have a good handle on polymorphism coming into this video, you will after we cover this. Polymorphism. Variable type tells us what methods we are allowed to call, and object type tells us what will happen when we call those methods. All of this fits together in this example. Then two of my favorite design patterns, factory and command pattern, we're going to use those. So I will also say this is an unusual video for me. I usually target videos to be between 5 to 10 minutes. When it gets to about 15 minutes, I get really anxious and I cut it off because I want these subjects to be easy to find. But this video is going to be a long one because it's kind of like a capstone video. I want to show how all of these concepts work together, and the best way to do that is with one video. So forgive the length, pause it, come back to it if you need to, but if you watch this entire video, I think it's really going to give you a good handle on all of these complicated concepts. Now let's take a look at our problem statement. We have a directory. Could be on the cloud, could be on a shared server, on a local computer, over the internet, anywhere else like that. And it has, at this time, 3 types of files: annuity, employee, and life insurance. So an annuity is where you receive a payment, scheduled payment, over a period of time. If you think like lottery winnings, where it says $1 million payable over 30 years. Or you think about retirement, like Social Security, where you're getting that Social Security payment until your death. So that's an annuity. Many insurance companies will offer an annuity product. Many investment companies will also offer an annuity product. So retirement planning, you tend to hear that term a lot. Life insurance. With life insurance, you have a policy that has an amount, and you're paying into that policy until a certain event happens, usually your death. So life insurance is the opposite. That's where you're making regular payments, and then you get a lump sum at a certain period of time. Once again, life insurance companies offer this product. And then we have employees. And employees are the people who work for the company, and they get paid. So each of these 3 types have something that happens to them once a month, in our example. Annuity, it's sending out that payment, maybe a check. Employees, it's sending a direct deposit to their bank. And life insurance, it's sending a bill for the life insurance premium that the customers are paying in. What we're going to find is that we don't know the order these files are going to come in, and we don't know how many files we're going to have. Could be 0 to many. I've created just a few samples. Now what we'll also see is that within the same file type, so for example within annuity, it's going to follow a similar format. First name, last name, and then annuity payment amount separated by spaces. All annuity files will have the same format. Employees will have a different format than annuity. So first name, last name, payroll amount, bank name, routing and transit number, and account number. So the employee format is specific to employees, which means it's different from annuity. However, all employee files have the same format. They'll have different values, but they'll have the same format. And then life insurance, once again, different from annuity and employee because it contains information about a life insurance policy, first name, last name, payment amount for the life insurance payment, and then policy type, term, which means that this policy is in effect for so many years and then it just expires, or whole life, which means that it's always in effect and payable upon your death. So 3 different types of files. Each file type has its own format, which is different from the format of the other file types. And we need to write a program that simulates processing these files in whatever order they'll come in. And it needs to know about the details of the files, but in the right places. So that's how we're going to apply our best practices, is by writing this program that will process these files. Let's get started at the most obvious place, and that is creating the main class, or the verb class that's going to kick this all off. If we take a look at our class diagram, it's this class called runner. We'll start with that, and then we'll create the others after we've created the runner. I have this set up as a Maven project, so I'm going to look for source main Java, right-click, and then say New Package. Call it Monthly Items. Under Monthly Items, make a new class called Runner. And live template PSVM will give us our public static void main. Main should really not be a big method. It just starts things off. It's not very reusable. So let's delegate to a new method called process. And Alt-Enter will create that method for us. Inside of this, we need to read this file of directories here, and input data is essentially at the root of our directory system. The files are here in this project to make things go a little bit faster, but normally we'd be reading from some other location like a shared drive or an internet resource or something like that. Since it's relative, if we want to get a list of files that live under that input data directory, we first need to get a reference to it by using the class called file in package.java.io. Now, there are some newer file handling classes in java.nio. There's files, there's paths. They perform non-blocking operations, so essentially you can read while somebody else is reading or writing. We'll save that for a different video here. Again, we're not worried about file operations as much as we are thinking about solid principles, object-oriented design, and programming without if tests. We'll focus on those. We get a list of the files, and now we can iterate over them. Now, all right, a couple considerations here. We kind of know a little bit about the future. We know that we're going to have 3 classes that implement an interface, and that interface is going to be called monthly command. Now, if we think about solid principles, we know dependency inversion means that even if we're dealing with those individual classes that implement the interface, from our verb class, from our runner class, we should only deal with the interface. In other words, the interface is our variable type. We know through Liskov Substitution that any of the classes that implement that interface can be substituted for that interface. In other words, if we have a variable with that interface as the type, any of those classes that implement that interface, we can create an object out of it and store it into that variable, and that's Liskov Substitution. We also know with interface segregation, which is a third of the solid principles now, that an interface should not force a class to implement any more methods than it needs to. Or said another way, if we're dealing with the interface type, it's going to expose only the methods that we need to call or we can call. It's going to hide any other methods. What other methods? Well, any methods that are specific to the subclass. This is very important here in this example, because our runner just wants to kick off a monthly process. It doesn't really care what's going on with that monthly process. It just knows it's kicking it off. So all it needs to know about is this interface, which we've not yet created. We will in just a moment. But this interface called monthly command. This is also central to the command pattern. The command pattern is one of my favorite patterns of all times. And looked on the internet, I found several different definitions of this pattern. But essentially with the command pattern, one class is kicking off some type of behavior without having any idea what that behavior is actually doing. Some of the things I saw online were, okay, allows requests to be parameterized, things like that. But this essentially is the command pattern, what we're doing now. We're going to save an object in a variable of the interface type. Interface has one method called execute, which again, we're going to make in a minute. And our runner class is just going to kick off this execute without knowing the details of how each of the subclasses are implementing this execute method. Now you heard subclass and method, right? That reminds us of another term, polymorphism. Polymorphism, variable type, tells us what methods we're allowed to call. If the variable type is an interface, then the methods in that interface are the methods we're allowed to call. Object type tells us what's going to happen when we call those methods. So our annuity, our employee, and our life insurance class that we're going to make in a moment are going to define the details of parsing an annuity, a life insurance file, and an employee file. But all of that knowledge will be encapsulated in each of those classes. And that's how we avoid if tests. We put the logic that knows how to parse a certain file in a class that represents that file, and only in that class, so that we don't have logic polluting other classes. And the way we can usually tell if we have logic polluting other classes is look for the if tests. Sometimes if tests have a good reason, but if we see a whole lot of if tests, we need to think, do we have the right class hierarchy going on here? So we have some details we need to fill in yet, but let's just say that this interface variable is going to be called monthly command, and then we're going to invoke an execute method on that, and we're going to pass in the file that we're currently processing or iterating over in this loop. So I know that's going to break. I know it's going to redline for a bit until we fill in this monthly command. Now, anytime we're dealing with files, there's a good chance we're going to have an exception, maybe file not found exception, or we've reached the end of the file or anything like that. A checked exception in Java typically happens when we're accessing something outside of the JVM, the Java Virtual Machine. Accessing a file, network connection, database. If something goes wrong there, we're going to find out via an exception. So I'm going to be a little bit proactive here because I know we're dealing with files. I'm going to go ahead and wrap this in a try-catch block. Now, where we put the try and the catch is really important here. Notice I put it within our for loop, and that means if we have a single file that causes us a problem, maybe it's corrupt or maybe just doesn't exist, we're going to skip that file and we're going to move to the next and keep processing. Think about that. Is that the behavior you want? If we have 1,000 files, if we have one that has a syntax error, do we want to skip processing everything that comes after that? Because those are kind of atomic. Those are independent files, right? So maybe we want to skip the one that's giving us the error and continue processing with the others. That's why I put the try-catch inside of the for loop. Let's consider the alternative, and that is if I put the try before the for and the catch after the for. What that would mean is if we do get an exception, it's going to jump to that catch block, which means it's going to break out of the for loop, and it's going to stop executing the for loop. And it's going to stop executing any files that follow the file that had the error. Now that we have the basic framework for the runner class, let's go ahead and create some other classes and interfaces. It's going to look a little bit like this. So our runner is our verb class. It's the thing that is going to start up and read our files. And then monthly command is an interface, and that's going to have an execute method. Execute method is going to accept a file parameter, which is going to be sent to it from the runner. We'll have 3 classes that implement this interface: annuity, employee, and life insurance. Now, keep in mind that monthly command is just an interface, so these classes independently can still have their own superclass hierarchy. As a matter of fact, we could take annuity and life insurance and both have them subclass a class called customers, because an annuity is a customer, or life insurance is a customer. Employee may or may not be, so we don't want to draw a line there. But nonetheless, that's an advantage of using interfaces, is we're not interrupting that existing inheritance hierarchy. So I'm going to start with the monthly command interface, and then I'm going to create the classes that implement them. And I'm going to do so in fast forward because it's a lot of typing and I want to make good use of your time during this video. But what we can tell from this class diagram is really the important part, which is that each of these classes have something that happened at the end of the month or at some point during the month. And each of these classes are somewhat different because an annuity is issuing a payment, an employee is receiving a salary, and a life insurance customer is getting invoiced. So that's the most important thing to see from these different classes. The interface is easy. Right-click New Java Class, Interface, Monthly Command. Now define our method, which is a method that each of the implementing classes is going to have to implement as well. It's going to receive a file, and that's a file that contains the data to be processed. Because we're doing file operations, there's a likely chance we could have an exception, like an end-of-file exception or file not found exception. I'm going to go ahead and add a throws exception to the signature. Also, we typically will put JavaDoc on an interface, both the interface itself and on the method itself, because this is considered the official API. That'll take just a minute, so I'll pause the video and do that. And there we go. Now with the interface, I can declare each of the classes. As a matter of fact, I'm going to go ahead and create each class all at once. Then I'm going to go through and fill in the details. As I mentioned, it's kind of routine. Once I make one class, they're going to look similar except for those attributes. So I'm going to do this part and fast forward. Start with annuity, and we need to set up that relationship with monthly command. So I'm simply going to add implements monthly command. We'll do this for each of the classes I'm about to create. Now it's going to whine at me, and we don't like red lines, so I'm going to go ahead and Alt-Enter and say implement methods. Remember, if we are implementing an interface, we're under contract to provide some implementation for all of the methods of that interface. so the project won't compile until I do that. Now we have the basic structure created. I'm going to go ahead and fill out the annuity class and explain that one, and then do employee and life insurance in a bit fast forward. The file we're processing is going to be passed into us, and that's going to give us a big hint on what we're going to need to parse. So we see first name, last name, and then payment amount, first name, last name, payment amount, first name, last name, payment amount. So back to our annuity, we're starting with this file, and an easy way to read a file is with a scanner. Import the scanner. Scanner.next says just read the string, right? Read essentially here, start from position 0, read a string until you encounter the space. If we had another delimiter, we could use like a split on the string to split based on a comma or a semicolon or a tab or something like that. But keep it simple here because we're not worried about parsing a file. We're worried more about writing a program without if tests. After that, starts at the last position where it left off, reads the next string, which we'll call our last name. Then the next thing is an integer, which represents that annuity payment. We could make a case for it being a double or a float, but we'll deal with whole numbers. We're good with that. Finally, let's give some output. We normally wouldn't read a file and do output in the same method, but okay, for a simple example, we'll go ahead and do it. SOUT gives us our live template to help us out a bit. And then system out println uses each of the 3 variables that we have received from this file. Easy as that. The other classes, life insurance and employee, are going to be very similar, only they're going to know how to parse their files. So employee, first name, last name, payment amount, bank, routing and transit number, account number. Again, similar format, but different value. First name, last name, payment amount, bank, routing and transit number, payment amount. And then life insurance is going to be first name, last name, invoice amount, and type of life insurance, whether it's term, which means that basically after a certain point the policy expires, or whole life, which means payable upon your death. So you can see here in the employee class, we're parsing the employee file. We get the first name, last name, and the salary, bank name, routing transit, and account number, which is going to be unique to an employee who gets paid by ACH. Now, no surprise, if we take a look at life insurance, we'll see that we are parsing for first name, last name, and invoice amount. And then we're printing a message that's particular to those fields. So each of the classes we've created, annuity, life insurance, and employee, knows specifically how to parse their own type of file. Annuity parses annuity, employee parses employee, life insurance parses life insurance. And they get the fields out that are unique to that type of class or that type of file, and then they print a message that contains those unique fields that are unique, again, to those subclasses. Now, in real life, this would actually, instead of doing a system out println, this would kick off some kind of action, either actually performing the ACH, maybe via a service call, or generating a bill, or maybe it does automatic direct debit for life insurance, and maybe even direct deposit for annuity. So it would oftentimes really kick off a downstream system, which is a bit more complicated than we need for this exercise. So to simulate that, I'm simply doing a system out println that says, hey, I'm life insurance, here's my invoice amount, or I'm an employee, here's my salary, or I'm an annuity, here's my annuity payment amount. Now that we have classes that can process each of our files, we need a way to figure out what class to instantiate or create an object out of to process each of those files. This is where the factory pattern comes in. So the factory pattern is a creational pattern. It can create a series of objects that share a common interface and return it simply as that interface type, which is exactly what we need in this case. And it hides details on how the object is created and which object is actually created from the calling method. So the calling method only needs to deal with the interface type, which simplifies things significantly. Now, we might still have an if test that could crop up here, because we could say if the file starts with annuity, then create an annuity object, else if the file starts with life insurance, create a life insurance object, so on and so forth. And right off the bat, that might be what you're thinking is, yeah, that's how I'll do it. And that's a perfectly logical way to think. But there's a hidden secret here that's going to help us out. It's a concept called reflection, which is really cool in the Java programming language. I remember when I found out about reflection, it really kind of changed my perspective on how I could do things. So with reflection, we use this kind of construction. We start with class. Now, that's the name of an actual class, unfortunately. There is a class called class, so that can get confusing. But anyway, class, which is often used to describe a class. Then we can invoke the forName method. With the forName method, we pass in a string. And the string represents that class's name. Fully qualified class name, so package name plus class name. And then we can invoke new instance on that, and it will construct an object out of the class that we have provided with that string to forName. It helps out a lot if it has a default constructor, because then, boom, it just creates the class, and there we go. So it's a lot easier in that case. Let's implement this. I'll create a new class called monthly factory. Now we need to put a method into this class, and the description of the factory pattern will help us out a little bit. Create an object. Return it as the common interface. So our return type needs to be that monthly command interface. And then we're going to hide any details from the calling method. Public, I'm going to make it static because we don't need to create an object of this monthly factory to then invoke this factory method. That'd be kind of redundant. So we'll just go ahead and make it static. Return type needs to be the interface. Descriptive method name like create monthly command. Then we need some kind of flag or some indication on which object we need to pass in. We'll keep it ultra simple and just say string name. Now, we just use reflection. Remember that all of our classes are in a package called monthly items, so we need to prepend that to the class name. One thing to be cautious of, remember that we use a period to separate package from class and also to separate the different levels of packages. So what we're actually going to do is monthly items and then a period, all of that in quotes, and then name is simply this string that's passed into us. Next, we tell it which constructor to invoke, and that's kind of new. We used to just say .new instance, but now we have to say get declared constructor, and then we can say new instance, and that will create a new instance of whatever object matches this here. Now, we could do this in one or two steps. We can say store it into a variable and then return that variable if we wish. Or we could just say return class.forName, so on and so forth, and do it all in one line. Whatever you prefer. Nonetheless, we do see we have a red line, and if I Alt-Enter, it appears that this could throw an exception, which makes a lot of sense because a lot of things could go wrong here. What if you pass in an invalid string and there's no matching class? How do we handle that? Well, we shouldn't just return any old object because that would not be accurate. There is not an object that matches if that class name passed in or the string passed in does not match an actual class name. So this is when we have an exception condition where we simply can't create an object. So what we do at that point is say, not enough information, I don't know what to do. I'm going to throw this exception back to the calling method, and then the calling method is going to need to decide what to do. It could elect just to skip this file and move to the next, which would make sense, and it would mean we could continue to process all these files, even if we have one that doesn't have a processor. Another idea, which may be an even better idea, is to take all of these times when it can't find a matching file and output that somewhere, like a log or a queue, so that we can start looking for files that don't have a processor, and we can get ahead of that and say, hey, what about these things? Don't we need to process those? But for the time being, let's be simple and Alt-Enter. And I'll simply add the exception to the method signature. Looks like we might have one more exception here. Add another exception to the method signature. There we go. And yet another. On to our next error now. And we see that something weird here. Let's see. If I choose Alt-Enter, what does it suggest? Well, it says that class.forename.getDeclaredConstructor.newInstance returns type java.lang.object. Remember that one? Java.lang.object? That's the capital O, the grand ancestor of all of our classes in Java. But we want a monthly command. So the way we used to handle this was with a cast. We would say monthly command, class.forename, and basically that takes whatever object comes back from this class.forename getDeclaredConstructor new instance and tells it that it's a monthly command object. If it is indeed a monthly command object, hey, great, we're in good shape. But the risk is, what if it's not? What if it is a car? What if it's a coin? What if it's a person? You can't force something into a type that it's not. If you do, you get a class cast exception. So we try to avoid casting. And there is another option that we can use. I mean, that'll work. You just have to watch out for that class cast exception. The other option is we add another method call to this chain as subclass, and then we pass in monthly command .class. As soon as we have that, red lines go away, and now our factory method is complete. So the next thing we need to consider is back in our runner class, how do we invoke this factory method? Let's start by calling that method we just created, and remember it's static, so we don't need to make an object out of monthly factory first. So now we're invoking create monthly command. We pass in some kind of parameter here that represents the subclass type we want to create, life insurance, annuity, or employee. We store that into this monthly command variable of type monthly command. Remember Liskov Substitution from the solid principles, which says that any subclass type should be substitutable for its superclass type, or same for an interface. Any class that implements an interface should be able to substitute for that interface. So at this point we're good because we're only dealing with this monthly command type. We have no idea if it is life insurance, employee, or annuity, and then that also goes to our dependency inversion from the solid principles, which is that our class we're in right now, the one called runner, should deal only with the interface type. It should not deal with any of the implementing types that are more specific, because all this needs to know is about that interface monthly command. So we're good there. We can invoke our monthly command execute, but we still need to find this string to pass down to our factory. Well, we do have a convenient little secret there. Remember the files that we're processing: annuity 01234, employee 01237, life insurance 0. Each of them starts with the type of file they are and then a 0. So what we need to do is read the files from this directory. Look for the first 0, take everything before that first 0, chop it off, put it into a string, and boom, there's our parameter for our factory method. Well, we're halfway there. We're already iterating over all these files. f.getName gives us the file name. We'll store that into a variable. Next, we use a little string manipulation in Java, which I will tell you is tricky if you've not done it before. Run it in the debugger, design it, plan it out. With strings in Java, we start counting with 0. So the very first character you see is character number 0. When we do a substring operation, that first number is inclusive, which means we start at whatever that first number is. But the second number is exclusive, which means we stop right before that second number. So it's confusing. I've tried to explain this one for a good 25 years and haven't found a good way to do it yet. But basically what we're doing with our substring is we're saying take the file name in this case, start counting at position 0, or the very first character, and continue until the character before the number 0. And by number 0, I mean the number 0 in the file name, not the character at position 0, but the number 0. Could be any kind of delimiter, could be an underscore, could be a letter, could be anything. In our case, I just used the number 0 in that file name. So that's going to grab annuity, life insurance, or employee, immediately out of that file. And then we can pass that down to our monthly command. And with that magic, everything compiles. I think we ought to try it out. And this is definitely a good use case for the debugger. You know, I'm a big fan of the debugger. I think it's the easiest way to learn something that you didn't write, but somebody else wrote, and you're trying to learn it. And in this case, this is such an interesting example. I think the debugger is really going to help us here. So we start by getting our directory where our files live. Okay, now let's list the files. And we see here annuity, annuity, employee, employee life insurance. And remember that 0 is our delimiter. So when we have our substring, it's just going to grab annuity and stop right before the 0. Employee life insurance as needed. Now we're iterating over these files, so we're going to shake hands with them one at a time. The first file we get is annuity 01234. Now, let's see if I can give us some room here, but watch line 46 very carefully. Remember, we're starting with the character position 0, which is the A, and we're ending just before the number 0 here in this file name. So the substring function should just give us that word annuity and put that into factory param. And sure enough, we see there's annuity. Now let's go ahead and step into our factory method. And now here's where things get really tricky, and we really have to check my spelling on this one. Monthly items, all lowercase, that does match our package name. And then the name that's getting passed in, which again is annuity, which we got from the file name. And then as subclass, get declared constructor, new instance, so on and so forth. So a lot of risk on this line. Let's go ahead and step over. Whew. Hard skip to beat there, but we're okay. We return this object that we just created, and take a look at what it is. It's this annuity class. Okay, awesome. So we go ahead and step over, and do we have our monthly command? We're back on our runner class now. We do, and it's an annuity. Okay, so big question. I'm now about to invoke execute on this variable. The variable is a variable of type monthly command. Monthly command is an interface. Interfaces typically don't have behavior for methods. They just have method signatures. But we know that the annuity class was instantiated as an object and saved into this variable in our factory method. And we know through Liskov Substitution, through Dependency Inversion, and through several other things, our runner class doesn't really need to know that it's dealing with an annuity. It just needs to know what that interface is doing. So when I press step into here, I want you to watch the tabs across the top and see where the debugger takes us. We're right now in our runner. I choose step into, and where are we? We're in the annuity class. So we step one line at a time. We see we parse this out, and then we do a print statement, and then we're good. And I'm going to continue. We'll go back to our runner. Let's see the next file. We've already seen annuity, so I'm going to do fast forward over these annuities. Next file probably is also going to be an annuity. Yeah, because it did alphabetize them. It doesn't have to, but it did. And we don't want to assume it's going to alphabetize, but in this case it did. Next file is, oh, it's an employee. Okay, so we should be able to parse out that word employee, and sure enough we do. We go to our factory method, and no surprise here. This time around, it's going to create an employee object instead of an annuity object. And once again, on the execute method, watch closely as I step into. Watch the tabs across the top. I go from runner to, guess what? I go to employee. And so we step over employee. We do a bit of magic there for employee, and then we go ahead and continue. And back to our runner again. The next one's likely also going to be an employee. Sure enough, it is. So nothing crazy here. We've already seen that one. And then the last item is going to be life insurance. Okay, so we should be able to take life insurance out of that file name, which we do. We take that as a key, and we go to our factory method. Factory method creates a life insurance type. Okay. And then we go to execute. When I step into, once again, watch the tabs across the top, and we see that life insurance knows how to parse a life insurance file, and then in this case send a bill. And we go back to our runner class, and now we're essentially finished with those files, so I can go ahead and terminate the program. Now, one note is you might say, okay, Brandon, that's cool, but your file names very conveniently had the class name in them, and that's not always going to be the case, is it? Well, now, made for a simple example here. But even if that's not the case, you still have a way to work with that. When I worked at the bank and I put together the program I was talking about that had 9 different steps of the process, the files were named goofy names. It was like something, something, something underscore 9 or 9 underscore something, something, something. So all I had to go with was a number. But the number was embedded in that file name in that case. So what I did, you can't start a class with a number. You can't have 9.class. That's illegal in Java. The first character has to be an alphabetic character. So what I did is I just made classes that were called process 1, process 2, process 3, process 4, all the way up. And with the class.for name, I just took the word process and I added it to whatever I was able to grab off of that file. Now, even if it weren't a file, if it were maybe a row within a file, there's typically something in that row or in a database or something that says, here's who I am. And that's usually what you can use as a parameter to decide, okay, which class is best to handle me. Now we get to see our adherence to good object-oriented design really pay off well. So, single responsibility from solid principles, as well as polymorphism, inheritance, and several other concepts we've covered, and that is in responding to change. And once again, this is based off of a real-life example that I mentioned earlier, where I was working for a bank, and in this case, I had written a program very similar to the one that we're writing now that handled 9 steps of a process. And when it went live, I got a call from the business owner, and they said, oh my gosh, we completely forgot to tell you there's a 10th step. We need you to handle this 10th file type. How long do you think that's going to take? And it really only took me a small amount of time, because all I needed to do to handle that 10th file type was make a single class that would recognize that file and be instantiated when it found that file, and then process that file. As a matter of fact, I made that class, I deployed it, didn't even have to turn off the application, and that 10th file type was consumed, had it all done within about 2 hours. So let's look at that with our example. I'm going to add a new file called mutual fund. This represents a mutual fund name, maybe a ticker symbol for an exchange-traded fund or something like that. Then its closing price, so price at the end of today's business, and then this individual shareholder's average cost, which is going to be specific to a shareholder because it's going to be based on the purchase history of that shareholder. Then the first name and the last name of that shareholder. So just like other files, this is a different format than life insurance, annuity, and employee, but all mutual funds will have the same format. So how do we handle this? I bet you can take a good guess. We create a new class called mutual fund, and we have that implement the interface monthly command, implement methods, that gives us our execute, and now we parse the file. So I use a scanner, I read in each of the values, I set them to properties that I've created on this class, I print out those properties or format those properties in the toString, and then at the end of the execute method I invoke that toString. Right click and run, and sure enough, take a look at what we have. The closing price for ATCO at the end of the month is $14.56 per share. Mabley Carew's average cost per share is $12.10. So in this video, we've seen how programming without if tests, but with good object-oriented design, makes for a more flexible and adaptable program because all of the logic is in the right place. We've explored all of the fundamental principles of solid, as they're all relevant to this example. We've also looked at polymorphism, where a variable type tells us what methods we're allowed to call, and object type tells us what will happen when we call those methods. And this is extremely important when we talk about programming without if tests, because the decision logic essentially lives in each of those classes that either implements an interface or subclasses a superclass. And also we've seen how our design patterns, the factory creational pattern and the command behavioral pattern, can come into play and help us to design a program that is flexible and can respond to needs in a short amount of time with minimal lift test, minimal complication, and minimal code. So as always, I hope you found this video helpful. This is a summary of something I did back in 2001 that really changed my perspective on programming. And I hope this video, however long it is, helps you to change your perspective as well, or maybe even just consider a different perspective. So, I hope you found this video helpful, and as always, I look forward to reading your comments. Thank you.